So welcome to the after break session about the Cloud Initiative. My name is Erich Barnstedt. I am the chair of the Cloud Initiative. And Steve already mentioned it in his keynote. The question is, do cloud providers talk? Yes, they do, especially in the OPC Foundation. AWS, Microsoft, Huawei, Google Cloud, we're all in the steering committee of the Cloud Initiative. We talk on a weekly basis about interoperability and how interoperability can be accelerated also for cloud applications using OPC UA technology. So in the next half hour, I'm going to tell you exactly what we have in mind in relation to that. So we started the Cloud Initiative just over a year ago. So we, really, thought that, pretty much driven by what our end users, our customers are telling us. They said, it's all great that we're now standardizing, the edge and OT environments, but how about IT environments? How do we standardize those in terms of accelerating interoperability for these cloud applications that everybody is building? So we said, okay, let's focus on interoperability of cloud applications, but we went further than that. We also said, how can we use all these wonderful companion specifications that the OPC Foundation is releasing? And you saw the slide from Stefan, we have several. How do we accelerate the use of these companion specifications also in cloud applications? Because like Stefan mentioned, the protocol doesn't really matter, but it's the semantics, the data model, which is the core of interoperability, of data interoperability. So that comes from the companion specifications. So we want to accelerate the use of these companion specifications in cloud applications. And of course, very quickly then, people said, okay, that's great, but how does it all fit together? So we said, yes, we need a reference architecture. And we also went through a process where all the steering committee members mapped their services to this reference architecture. Plus, we created a reference architecture just built on open source components, because not every vendor has all components in their portfolio. So we can fill the gaps with open source offerings very easily. And then we also created a protected identity similar to what the Field Initiative did with Field Exchange. We created Cloud Exchange as something that people can use in marketing activities. And then finally, we're not finished yet, but we started a certification program where we're defining test cases similar to what is done for OT environments with OPC UA servers that you can basically buy today that are certified for OPC UA compatibility. We want to do exactly the same for cloud applications, so you can certify your cloud application to be OPC UA compatible. So Stefan already showed this slide. So we're on a good path. We got a lot done in a very short amount of time. So, the reference architecture is complete. We have a brochure which explains it in detail. You can download it off the OPC Foundation website. We've also done a lot of work on cloud application communication. This is sometimes referred to as the industrial data space. So I'll talk a little bit about data spaces in a minute, but fundamentally a data space is two cloud applications talking to one another. It's not a data lake or anything like that. It's really a point-to-point communication, usually along a supply chain, right? So if you have a vendor selling a gearbox to you and you're an automotive OEM, you want to put that gearbox into your car, you're going to need some information regarding that gearbox, specifically, what its specification is and so on. And that information can be transferred using industrial data space technology. Peace on earth and goodwill towards men needs some improvement. We're working on that. So as you can see, here's a overview of some of the steering committee members. As you can see, we have AWS, Google Cloud, Huawei, Microsoft, and SAP from the cloud vendor perspective. But we also invited the traditional automation suppliers into the steering committee such that they could also map their services, because they're also growing into the cloud. So we have ABB, Beckhoff, Honeywell, Mitsubishi, Rockwell, Schneider, Siemens, and Yokogawa in the steering committee of the cloud initiative. And Stefan mentioned it already, nowhere else do we have this amount of OT and IT companies under one roof working on joint architectures and services. So we're really proud of that. But we didn't stop there. We also said we need feedback from end users if we're on the right track. Are we building stuff that people can actually use? So we created an end user council and invited manufacturers that are in the OPC Foundation to join this end user council and give us feedback. So we have regular calls with them and say, hey, we're thinking of doing this. Would that fit? Would it not fit? What can we do better? Where do we need to focus next? Those kind of questions. And they're giving us really valuable feedback, and we're really grateful for their participation in the cloud initiative. So overall, we're on a good track. We've got a lot done. And I want to tell you a little bit more about where we are right now. So there are several working groups in the OPC Foundation that are already working on cloud technology, but they were pretty much by themselves. There was no coordination between the individual working groups. So one thing we did as a first step was to combine them under the roof of the cloud initiative. And we're synchronizing with all of these working groups and making sure that the output of these working groups is aligned with the reference architecture of the cloud initiative. So for example, we're working with the MQTT binding working group, which is part of the PubSub Part 14 specification. We've gotten feedback from these end users that I mentioned earlier that Kafka would be another important protocol to map to. Now we have a mapping to Kafka. It's the same PubSub transport, it's the same payload, but you can also use Kafka now as a protocol. So, I mean, obviously there's MQTT, there's AMQP, there's UDP, and now there's Kafka. We realized that, open REST interfaces have a specification which is kind of the de facto standard. It's called Open API. It's an open specification. Most REST interfaces and cloud applications that you see today use this Open API specification. There's also a JSON file that you can use to generate stubs automatically using code generations and so on. So we went and took the REST interface, which was part of the OPC UA spec since 2015, nobody knew about it, and we turned it into an Open API compatible REST interface and put it into part 5, I think, 5 or 6 of the OPC UA specification. The cloud library was initially just meant as an online store of OPC UA information models. But it's since grown and is now multi-purpose. I'll talk to you a little bit about that in a minute. But we created a new version of the cloud library specification, obviously keeping backward compatibility. We created an AI working group. They're working on things like OPC UA mapping to the MCP protocol. Stefan mentioned that already. We updated the metaverse demo. So we have an industrial metaverse demo that we showed at HMI 2 years ago. We've updated that demo with the latest technology. The metaverse is a pretty new area, so there's a lot of movement in technology and so on, so we needed to update that. We've done that. And then something close to my heart, which is the WAT connectivity. I'll talk about that in a second, but it's mainly used for brownfield assets that don't have OPC UA connectivity built in, but you still want to map those assets to OPC UA, and WAT connectivity is the solution there using Web of Things, which is the W3C standard. WAT binding is pretty much the other way. So WAT connectivity kind of shows you how to take a WAT file and map it to OPC UA. WAT binding does exactly the opposite, because there are scenarios that require the mapping in the other direction. We have a mapping for the asset admin shell. That work is nearing completion. Plus, like I mentioned, we're growing into the supply chain, into industrial data spaces. Digital product passport is something we're going to hear a lot more today. It's a European requirement coming in 2027, starting with batteries. but eventually all products sold in Europe will have to have this digital product passport. It's basically a QR code on the product which will tell you, or will send you to a website. That website has information about the product, including things like carbon footprint and recyclability information. It's really an initiative from the European Commission to accelerate circular economies, because you want to reuse as much as possible. And we have marketing activities like this event today, right? So obviously we want to talk about what we're doing so people know what they can expect from the OPC Foundation. Stefan already mentioned this, so the data spaces work really is driven by the International Data Space Association, and it was clear that we needed a liaison with the IDSA, which we've done, and we're starting to build out technology for data spaces, and particularly to allow customers to use OPC UA technology in data spaces. Catena-X is the automotive network for industrial data spaces, so specifically for automotive OEMs and their suppliers. We're collaborating with them since a year ago, and this is also helping with things like the digital product passport, because they also want to be able to say, our data space for the automotive field is compatible with the digital product passport and fulfilling the requirements from the European Commission. So they've built technology based on what the IDSA is delivering. The IDSA is working with the Eclipse Foundation, and now we're also helping with open source software and technology in the OPC Foundation. So together with the Eclipse Foundation and Catena-X, we're delivering a solution for things like the product passport. So let's talk a little bit about digital product passport. So again, it's a European initiative. It's going to be mandated. That's what harmonized standard means, this thing here. It's a mandated thing. If you don't comply, if you don't have a digital product passport, once it comes into effect, you will be fined. And you may not be able to sell your product in the European community, in the European Union any longer. So it's a big deal for manufacturers. The battery regulation is now in force. The battery passport is going to be mandated for all batteries over 2 kilowatts in size, kilowatt hours in size, from February 2027 onwards. So you have just over a year to build these battery passports. So battery manufacturers are obviously already looking into this, and we will hear later on from Fraunhofer about a factory that they're building right now, which will also automatically produce these battery passports. And then, of course, I already mentioned circular economies, recyclability of vehicles is a big deal. A car has a lot of raw materials that you want to be able to recycle. So all of this together is part of the European Green Deal, which is a huge initiative within the European Commission. And clearly, the OPC Foundation can deliver technology for this initiative. So what does it look like in particular? The proposal that we made is we will use whatever European Commission wants, plus OPC UA technology. So what the European Commission wants is a standardized HTTP REST interface, which is currently getting finalized. We will support that REST interface. But of course, we will use the OPC UA modeling language to model the data that will be provided through that REST interface. And of course, we're also taking whatever semantic information, the different verticals will come up with, and take that into account and use it with OPC UA technology to create the data that will then be available through this REST interface. And this combination of OPC UA technology for the modeling, the semantics coming from things like the Common Data Dictionary, but also E-Class, the VDMA companion specs, you name it, all of these sources of data will be automatically enabled, and we will allow this to be shared through things like the digital product passport along manufacturing supply chains. So far, this has been very successful. We call it Better Together. It's been about a year in the making. A lot of the European organizations that are involved in the manufacturing space think that this thing has legs. And we're really pushing for this to be the solution for the digital product passport. So the cloud library as a source of OPC UA information models really started back in 2001. 2021. 2001 would be a little old. 2021, 4 years ago. And it started with the Smart Manufacturing Institute in the US approaching the OPC Foundation and saying we have a need to accelerate the use of OPC UA information models. We want to create a marketplace of OPC UA information models also in the US. And we need a library that is hosted online for these information models. So we got together with SESME and created the cloud library. The cloud library, in a nutshell, is an online store of OPC UA information models. It now has all the companion specs that the OPC Foundation ever released in it. But also, I mentioned we're working with Catena-X. Catena-X have templates for the digital product passport, over 200 of them. There's a template for gearboxes. There's a template for, yes, the battery passport, for tires, for everything. Everything that makes up a car. All these templates are also now available as OPC UA information models in the cloud library. We're very proud of it. The OPC Foundation is hosting an instance, but SESME is also hosting an instance. So we have also fault tolerance. It's been operational for over 4 years so far. We haven't had any outages. So SESME created an entire ecosystem of tools and products around the cloud library. They also created an online OPC UA editor called Profile Designer. Now, you may think, what is a smart manufacturing profile? It's another name for an OPC UA information model. It's nothing but an OPC UA information model. They just have a different name for it. They created this online editor, which is great. They've recently contributed that online editor to the OPC Foundation, and we're just starting an open source development activity to make it better. And like I mentioned, they have a marketplace, so you can actually go into that marketplace, you can register for free, and see what other information models have been created in the meantime. So I mentioned there are several instances of the cloud library. There's one run by the OPC Foundation, uacloudlibrary.opcfoundation.org. It's free registration. You can register today. You don't need to be an OPC Foundation member. SESME also have an instance. And there's many private hosted instances. Yes, some manufacturers say the idea of the cloud library and having a central store for all OPC UA information models is a great idea, but we really don't want to share our information models with anybody else. That's okay. So they go in and they host the cloud library themselves, which is totally fine. Now, the cloud library is a multi-tenant service, and you can choose to not share the information models that you upload to it, or you can say, you know what, this thing is public domain, I'm happy to share this. It's your choice. You don't have to share it. It is an open source project. The cloud library source code is on GitHub, like many other things that we do in the cloud initiative. There's an open source console app which executes the REST interface that it has. There's also a client SDK, so if you want to integrate an SDK, that's no problem. There's a NuGet package for the client SDK. The cloud library itself runs in a container. There's a pre-built container available, so you don't even need to compile it. And we get quite a lot of commits through it, through GitHub. There's a very active community of developers working on it. We've recently moved it to .NET 9. It's a .NET application. .NET 10 is on the roadmap. We're working on that right now. So as you can see, there's a lot of momentum behind it, and we're very proud of it. I already mentioned these. One other thing that the cloud library does is when you upload an information model to it, it does semantic validation. And a lot of people use that feature alone to check if their information model is actually correct. So that's part of the benefit. Plus, there's a search functionality. There's a UI, and you can search for types, which is super convenient. So before you start developing a new OPC UA type, I don't know, for a gearbox or for a pump or whatever you want, electric motor, you can search for existing types across all information models in the cloud library and say, oh, there's an information model already for pumps. Maybe I shouldn't create another one. So it helps and encourages reuse of existing types that are defined in information models, particularly companion specs. So of course we build proof of concepts for digital product passports together with SESME. We actually produced a roll of paper. Looks like a toilet roll. It really isn't a toilet roll. It's a roll of paper. It's about this size. I suppose you could use it as a toilet roll, but maybe not. So we created an information model that describes the roll of paper, and then we stored it in the cloud library. We used the profile designer to do the modeling as an OPC UA editor, and the whole process took us 2 days. So it's really quick to use these open source tools. And the profile designer is also hosted by SESME. Again, we're going to make it better, and also hosted by the OPC Foundation. So really, when you're new to OPC UA, the profile designer is a great starting point. We find that most of the OPC UA editors out there are desktop applications, so you need to find them, you need to download them, you need to install them, you need to learn them. And there's usually a steep learning curve, especially for people that are new to OPC UA technology. That's generally a problem. So we said we need an online tool that people can just use, which is super simple to understand, and they can start modeling with OPC UA without being OPC UA expert. That's the goal. So we truly believe that this will help accelerate the adoption of OPC UA because we're lowering the bar of entry. Well, we didn't stop there. So we also created a UI for the cloud library. Here's a screenshot. So as you're browsing information models in the cloud library, you can also click a view button, and it will actually render the content of the information model right there on the website. And you can browse through it, you can click through it. For example, here is the template from Catena-X in relation to, speed back. Carbon footprint calculations. Carbon footprint is super, super popular right now, especially because it's required for the digital product passport. So you can view what's in there, in that template, right in the cloud library, and you can even create a copy of it, add some values to it, basically fill out your template right there in the UI of the cloud library, because quite honestly, a lot of the smaller manufacturers say, you know what, we're fine with the templates. We don't need to design and model an additional OPC UA information model. We just need to use one. So why not put this into the UI right there? People can just make a copy, fill in the values, hit save, and they're done. Here's the architecture of the cloud library. Like I mentioned, it's multi-tenant and it's multi-cloud. The only dependency that it has is it needs a Docker environment to run in, and it needs a PostgreSQL database to store its data. And that's on purpose. We really want the cloud library to be runnable on any cloud. So we're also working with the European cloud providers. They usually don't have the same portfolio like, the big hyperscalers like AWS or Microsoft or Google, but they in general can run containers, and in general they have a PostgreSQL managed instance that they can run their services on. So that's why we kept it super simple to make sure that as many cloud providers as possible can run the cloud library. I mentioned that we're working with the Industrial Data Space Association, and I mentioned that they're working with the Eclipse Foundation on open source. The product, or let's say the reference implementation that they supply for data spaces is called Eclipse Data Space Connector, and it works in harmony with the cloud library. So it handles the authentication and authorization of the two parties in the data space exchanging information. So for example, an automotive tier 1 supplier supplying a gearbox to an automotive OEM, and they will use the Eclipse Data Space Connector to basically create trust between the two organizations. Yes, we know each other, we trust each other, we can share information, and then the data sharing itself happens through the cloud library. That's basically how the two fit together. Here is the data plane SDK from the Eclipse Data Space Connector. They have their own REST API defined. We're integrating that right now in the cloud library. So you can think of it that way. If you're familiar with IT architectures, the data space connector is the control plane, which establishes the initial connection. And then the cloud library is the data plane that does the actual data transfer. You need both, unfortunately, but that's basically how it fits together. So let's switch gears. So here's another technology that we're working on. It's a W3C standard, which describes assets for use in any IoT environment. So it's very generic, but the key to it is it has protocol bindings for some of the simpler protocols like Modbus and MQTT, right? So these are the things that you want to have for assets that you want to map to OPC UA, but they will never have an OPC UA interface. For example, the popular choice I always have, where is it, is the Siemens energy meter. So this Siemens energy meter has a Modbus interface, but you still want to map it to OPC UA. And in fact, there is a companion spec for energy measurement that Siemens has contributed to the OPC Foundation. And with Web of Things, we can now map this Modbus device to OPC UA in a single click because the Web of Things file is provided by Siemens. So they don't just provide a PDF, which describes the asset and the interface, but they also describe a machine-readable Web of Things file that they make available on GitHub. So with Web of Things, you can map your brownfield assets to OPC UA fully automatically. The Web of Things file is JSON. Here's an example. And we've extended Web of Things to also have the information regarding the mapping to OPC UA right there in the Web of Things file. So you can see here, we're mapping this thing to the Profinet energy monitoring or measurement companion spec. And here, the properties in the Web of Things file are like the tags that you're familiar with. And you can basically say, okay, this is a voltage measurement, it's a number, et cetera, et cetera. Here is the address of where you find this particular tag in the device, in a Modbus device, for example. But you're also specifying how to map it to OPC UA by specifying the type information from the companion spec that you want to map the device tag into. So by providing a Web of Things file, you can now onboard all these brownfield assets. And yes, we created a companion specification which explains exactly how to do that. In version 1, we have just two methods, create asset and delete asset. And we're using the OPC UA file transfer mechanism that's been in the OPC UA spec for many, many years to provide the Web of Things file. So that's easy. But in version 1.1, we added some optional convenience method. In version 1.2, which is currently in review, we're adding mapping to method calls. So some southbound protocols that are not OPC UA don't work with tags, but they work with methods. And of course, you also want to map those methods to OPC UA. So how to do that is now specified in the 1.2 version of the spec. And this is kind of the reference implementation. So of course, we create the spec, but we also created a reference implementation. So the reference implementation for what connectivity is called Edge Translator. It's on the OPC Foundation GitHub. It now supports 11 southbound protocols, and it does the mapping to OPC UA fully automatically. But wait, there's more. Wouldn't it be nice if we didn't have to ask the supplier of the asset to provide the Web of Things file, if we could generate that Web of Things file automatically? Well, that's where things like ChatGPT can help bridge that gap. Because ideally, you get the Web of Things file from the asset manufacturer, sure. But if they don't, you can generate this thing fully automatically with ChatGPT. With GPT-5, it's 96% accurate. Yes, you still need to look through it. It's probably going to be incomplete, but it's a lot better than starting from scratch or trying to map the asset manually to OPC UA. If you've done that before in an industrial IoT project, you know what I'm talking about. It's a very tedious, mundane process, very error-prone, because if you get a Modbus register wrong or you have a typo in there, it won't work. With this, you're automating that step, which makes it a lot easier. And I'm happy to report, am I out of time? Almost. Okay. I'm happy to report Process is the first vendor to offer Web of Things in their product. So thank you for the support. And hopefully there'll be many others following your lead. But this is a big step because it enables this automatic asset onboarding step that we've been waiting for all these years. And it's in my opinion, it's the evolution of industrial connectivity right there, black and white. So this is the reference architecture of the cloud initiative that I've talked about. So as you can see, there's quite a few components in here. I'm not going to go through each one of them. I'm just going to mention a few. So industrial connectivity software, that's where things like Process Forge fit in. With what connectivity implemented. But fundamentally, if you take one piece from this, the overview that Steve showed in his keynote is basically this turned 90 degrees, right? So he's layered it top to bottom. This is basically left to right, but it is kind of one level down in the overview that Steve showed, or one level more detailed. So fundamentally, here's the edge. It has a pub sub, OPC UA pub sub data publisher, just like Uni mentioned. And we have a cloud broker, which basically accepts the pub sub data and then transfers it into a time series database. This can be a data lake. It can be just a simple time series database. You decide. But everything else that sits around it, the ERP database, the MES system, et cetera, that's all part of usually existing products that manufacturers have on their shop floor. And we've basically mapped it to the cloud initiative. That's what we've done. And of course, there's dashboards and so on. So the digital product passport that I talked about is right here in the reference architecture. The digital product passport library is the cloud library. The data space connector, that's the piece from the IDSA. So all of it is right there, and you can see how it all fits together, and that's what people are looking for. And of course, we've mapped it to services and open source. So if you want to get started with this architecture today, you can, just by using open source technology. So you're not dependent on any particular vendor. Of course, we encourage the use of managed services, so you don't have to carry the beeper and fix the service when there's been a security breach. That's usually what the cloud vendors do. but you can if you want to. So all in all, this is the entire point of the cloud initiative, is to bring these things together in a vendor-neutral way. That's why we're doing it. What are the next steps? Well, we need to finish our testing strategy document so we can get the compatibility testing going. We do want to leverage the existing OPC UA test labs for that. It's not going to be free, right? So if you have a cloud service that you want to test as part of the cloud, initiative, there will be a fee, just like there is a fee today when you bring your OPC UA server to the test lab and get it certified. You need to have a little bit of money in your pocket such that the test labs can sustain themselves. Like I mentioned, we want to make the SESME nodeset editor, the OPC UA editor that I talked about, we want to make that better. We've collected some money. Hopefully we can collect even more money to make the nodeset editor better and hosted by the OPC Foundation, so that anybody can go to the website, use it without charge, free of charge. And for the digital product passport, like I mentioned, the European Commission has standardized the REST interface that will be used for the digital product passport. That work has been done by CEN-CENELEC, which is a European standardization agency. We will, of course, implement the REST interface that they have specified in the cloud library once it becomes available, hopefully in January, February, they mentioned. Those are the next steps. The brochure's right there for download. I've been told I'm out of time. Thank you for your time.